Okay, so by now you should have watched the video, and the video hopefully explains why it is that we are interested in the angle, which is this polar form. So you saw in the video, hopefully, that if we plot just two complex numbers, using Cartesian coordinates, then the image looks very jumpy. You're just jumping from one location to another. Whereas if you break it up into angles and smaller angles, then you get, when you rotate an image, you get that smooth rotation, which is what we, I suppose, like to see in animation. So our rectangular form is our usual x plus yi form, or excuse me, we call that Cartesian form as well. Polar form is this or cos theta plus I sine theta. So I suppose we want to know, what is the connection though? How do we get from one to the other? Like, why is it that suddenly x plus yi is or cos theta plus I sine theta? So to explain that, I guess we're going to visualize the Argand diagram for a moment. So normally when we're plotting points, we go right or left first, and then we go up or down. So let's just keep it in the first quadrant. We'll keep it simple. So like, for example, I could go over 3 and up 4, and that would make the point 3 plus 4i. Now, I'm not going to use any numbers here, so we're just going to call this complex number x plus yi. Now, if I turn this into a triangle, I'm going to call that alpha for the moment. Hopefully, it makes sense then that that is x and that this is y. So in other words, I have to go x over and y up. Also, this here, we're going to call or. Now, this is, remember, our modulus. The distance of the complex number from the origin is our modulus. Why is it called or? Well, again, if you think of anything you rotate, like if you rotate a dot, it will eventually form into a circle. Sorry, my circle is very bad, but it's technically a radius actually, because if you imagine rotating that dot, it will make a pathway of a circle. So that is why it's called or. Now, when we go to do these this connection, so how does cos come into play? Well, let's imagine we want to get the cos of alpha. Children are happy. So that's adjacent over hypotenuse. So the cos of alpha, the adjacent would be x and the hypotenuse is or. If I cross multiply, I get or cos of alpha is equal to x. Now, in the place of x then, I can put or cos of alpha. Let's check out sine. The sine of alpha, somewhere is often hot, opposite over hypotenuse. Cross multiply, and I get or sine alpha is equal to y. So in the place of y, I can actually put instead plus or sine alpha. And of course, the I is still going to be there. Now, because they both have an or, we can factorize out the or, and we're left with cos alpha. Usually we put the I to the front, I sine alpha. Now, I've called it alpha in the formula. It's called theta. You can use theta, alpha. It doesn't make any difference. They're just Greek letters. So hopefully that explains to you that it's not like this just came out of nowhere. There is a direct connection between the rectangular form or Cartesian form and polar form. So in the next video, I'm going to show you how to go from Cartesian form to polar form.